Hello my dear students, welcome to Easy Technical Academy. Today we'll discuss about the energy transfer, that is work part 2. पार्ट 1 में डिस्कस किया था थर्मोडायनामिक वर्क. वहां हमने कहा था कि वर्क तब कहलाएगा थर्मोडायनामिक वर्क जब वहां पर कोई रेजिस्टेंस होगा. अगर रेजिस्टेंस नहीं होगा तो वो थर्मोडायनामिक वर्क नहीं होगा. चलिए हम इसको आगे समझते हैं और थर्मोडायनामिक वर्क के लिए एक इक्वेशन डेवलप करते हैं, जो इक्वेशन क्लोज सिस्टम के लिए होगी हमारे पास. ठीक है. So we have a piston cylinder arrangement and we have somewhat small weights which is placed over the piston. What will happen? We are supplying small amount of heat and we remove slowly the small weight. Piston will gradually move. Again we are supplying heat, again we remove slowly small amount of weight. Piston again move. This process takes place in a very slow manner. That is, you can say it is a quasi-static process. Almost very slow. And this process is very slow. That means we are in every process, when we are removing the weight, we are achieving equilibrium condition. And finally we reach to the point number 2. As the piston will move, our boundary will also move. Piston will move, boundary will also move. And we reach to point number 2 from point number 1. So what is my displacement? My displacement is dx. अब यहां पर हमें ऑब्जर्व ये करना है कि ये जो डिस्प्लेसमेंट हुआ ये किसके अगेंस्ट में हुआ. क्या कोई रेजिस्टेंस है? और अगर रेजिस्टेंस है तो वो क्या कहलाएगा? थर्मोडायनामिक वर्क. और वो थर्मोडायनामिक वर्क क्या होगा? रेजिस्टेंस फोर्स इनटू डिस्प्लेसमेंट, नॉट द अप्लाइड फोर्स. In thermodynamic work we have to consider resistance force. So we have piston is trying to expand, trying to move, and this gas will reach to the point number 2. The force exerted by the gas is P into A, and there will be a resistance force applied over the piston, which is restrict to expand the gas. And this is my resistance force. Now what are this resistance force? This resistance force are mg, that is piston load, w load, the small load to be removed slowly, then we have po into a, which is the atmospheric force or force exerted by the atmosphere. So under equilibrium condition, the force applied by the gas and the resistance force will be same. If there is not equilibrium condition, then these two forces will not same. So since we are dealing with equilibrium condition, so Pa into resistance force. Now what is work? Thermodynamic work. Resistance force into displacement. Resistance force into displacement dx from point 1 to 2. Now can we replace this resistance force? Because this is equals to what? Pa. So we are replacing this resistance force with Pa, and A into dx will be the change in volume. Change in volume from point 1 to point 2. So we can write del W is equals to what? P dV. And this is the equation for closed system work. This process is also represented on PV curve. What will happen? We are at point 1 number 2, point number 1, and we are reached to point number 2. And we are at point number 1, it is equilibrium condition. We reach to point number 2, it is also equilibrium condition. And we have to crosses number of small processes, then we reach to point number 2. This is a path 1, 2. So area under this curve represents W is equals to PdV. That is work done by the closed system. So since we are trying from 1 to 2, what will happen? Integrating 1 to 2, P into dV. So we got the relation W1 to 2 will be P V2 minus V1. Or we can say V final minus V initial. So majorly you have to remember this equation, that is del W is equals to P dV, which is the closed system work equation. Thank you.